what we have here, some guy by the name of Wesley is pushing a 100-kilogram wheeled crate on a ramp leading to the back of a truck with a force of 500 newtons. Question: if under his push the crate is moving at a constant velocity up the incline, what is the net force acting on the crate? Okay, now again, so this is my crate, and we have Wesley here pushing on it, and it is moving at constant velocity. The question is, what is the net force on the crate? Of course, net force is ma. I don't have an acceleration since I have a constant velocity, so my net force is 0. Now, while he was applying 500 newtons, the crate was moving at a constant velocity. What if he lets go of the crate? What are the forces acting on the crate then? Okay, let's consider the forces acting on the crate with no Wesley. Okay, what are the forces acting on the crate? That is going to be the gravitational force. Okay, pay attention to this. What's the direction of the gravitational force that the Earth exerts on the crate? It's straight down. It's not perpendicular to the ramp. It is straight down. So that's one of the forces acting on the crate. What's the second force acting on the crate? It's the normal force that the ramp exerts on the crate. So that's going to be perpendicular to the ramp and Fn ramp on crate. These are the forces acting on the crate. The only two forces acting on the crate. Now, by telling us it is wheeled, they are telling us to ignore friction. That's what they are trying to tell us there. Now, he was exerting 500 newtons. Suddenly, and the crate was moving at constant velocity. And he lets go of the crate. The question is, what would be the net force on the crate then? Now, the key here, when he was pushing it with 500 newtons in the forward direction, the forces were balanced. What does that mean? That means these two forces here, the normal force and Fg, they were contributing along the ramp. They are contributing parallel to the ramp with a force of 500 newtons that was balancing this 500 newtons. His push was 500 newtons this way. Constant velocity means that these two forces must contribute 500 newtons the opposite way. Now, the normal force is perpendicular to the ramp. The fact it's perpendicular to the ramp tells us it's not going to contribute at all to any force parallel to the ramp. However, the gravitational force is along the vertical, and the vertical is both parallel to the ramp and perpendicular to the ramp. So actually, the gravitational force is both pulling down the ramp and pulling perpendicular on the ramp. The gravitational force is acting both ways. So what this tells us It is the gravitational force that was contributing the 500 newtons parallel to the crate. Now that we removed this 500 Newton push, that 500 newtons due to gravity is going to remain unbalanced. So my net force is then just 500 newtons in the forward direction, parallel to the incline. I got it wrong here. 500 newtons in the downward direction, parallel to the ramp. Now, this is a little interesting. Okay, the other one was the difficult part. Now this should be a little simpler, but it's interesting. Under his push, the crate moves at a constant velocity of 4 meters per second up the incline. What if he lets go of the crate? What would the acceleration of the crate be then? Okay, now we know what our net force is, 500 newtons down the incline. What's interesting, think what's going to happen when he lets go of the crate. Since it's already moving, what it's going to do is continue moving forward while slowing down till it comes to a momentary stop, and then it starts rolling back down. Here the question is discussing what's going to happen the minute he's going to let go of it. So it's discussing what's going to happen now. Actually, the acceleration is going to be the same even while it is rolling down, but we are not focusing on that right now. Okay, now what would be the acceleration? Net force over m. Net force is 500 newtons. M is 100 kilograms. So my acceleration is going to be 5 meters per second squared down the incline. And what's the ensuing motion? I just described it a little while ago. Probably I should have put this before the previous question. What's going to happen? It's going to slow down from 4 meters per second till it reaches a momentary stop, and it starts rolling back down and speeding up. Okay. So just to summarize what we have discussed, what is the force that's responsible for the net force down the incline? It is the contribution of the gravitational force, because being vertical, it has a contribution parallel to the incline and a contribution perpendicular to the incline. It is the gravitational force that's resulting in an acceleration down to the incline. And intuitively, you know that's the case. You know that something is going to roll down the incline because of gravity, and this is what this example is trying to demonstrate.